Okay, so you just want to sand it until you, well, with these peel ply things, we want to get rid of the main texture of the peel ply to get a sort of smooth surface. If you've got a really, really smooth sample, then you want to use a sandpaper to roughen up the sample actually. So these are 400 Brits, but anything around 200 to 400 Brits is probably fine. You just want to get approximately the centre of the area completely clean, because if you've got powder and stuff in there, the super glue won't stick properly, and then you get bad readings. You can use a caliper for this. One thing I recently learned was never use a scribe or anything. I don't know why I didn't think that before, but I originally scribed my sample to put a line down it, and obviously that just wrecks your material, so don't do that, use a pencil. So you see on the top here, you've got all the circuitry basically, but on the bottom it just looks smooth. So the smooth side is what goes onto the sample. You can also see these little metal wires. You don't want them to be touching at the end of the installation. So
well, if they are, it's just remove them with the tweezers a bit.
yeah, so you try and use tweezers or a knife or something to like pull them apart, because if those are touching. Hopefully it's fine. So now we need to be able to push down on that to push the to put some glue underneath. So in order to do that without touching it, we just get more tape and put it over the top of the gauge. Oops. So actually the clear tape's probably a way better thing, because you can see it a lot better, because you have to look pretty closely to see through this blue tape. But once you've got it down like that, if it sticks to the sample, don't peel it up like that. Just try and hold the tape as straight as possible so it comes up. So yeah, don't pull it back at this point, because you don't want to flex the gauge too much. Done in a sort of rolling action, so you want to start with the glue near the back of the gauge, so then when you slide it forwards, it covers outwards onto the gauge. Because if now we actually do want to do that, so you want to peel it back as close as straight back as possible to try and avoid lifting the gauge. In order to, because it's such a tiny resistance change as that wire flexes, you effectively amplify it through a Wheatstone bridge. So you have to do them do these gauges in pairs to make one half of the Wheatstone bridge, which is 4 resistors. So each one of these little coils of wire on here is 120 ohms. So we need another thing to match that 120 ohms. So inside this block, there's a precision resistor, which is 120 ohms. So if you want to use a different type of gauge that is, say, 350 ohm, you have to either get a new one of these blocks or wire it up yourself by hand. Let's go. So we just put one end into pin 0. Tighten that up. So then this, wherever that guide went, describes that there's a jumper wire between pin 1 and 2, and this goes into pin 1 as well. So put that into pin 1 and put the jumper wire in.
So it's 0 and 1, and the jumper is going between 0 and 3, yes?
No, the jumper is going 1 and 2.
1 and 2. Oh, yeah, okay. Okay, yeah.
This is a National Instruments strain gauge input module. So there's 4 ports on it. We only need 3 because for rosettes it's just three gauges in different orientations. You can plug them into any ones you want. I'm going to put the central up and down pin into port 1, so that's green wire. So they're just sort of Ethernet type ports. Just click that in.
So does it matter which slot is going to go where?
You just have to decide for your samples. It's probably quite good to keep the central gauge so straight up and down into port 1, and then plus and minus 45. You can choose.
Okay, and we open the MTS.
Yeah. So the software is called TW Elite.
Yes. Might want to.
Like you guys, if you want to do some testing, if you actually want to like add strain gauge readings to a new template or a new measurement thing, or change the settings on the strain gauges, you should definitely get that guide out the drawer and follow it exactly step by step, and don't miss any of the steps because it can screw it up super easily. Even simple things like every single gauge has to be calibrated exactly the same, otherwise it won't read them, stuff like that. So it's called a TEDS device, so those strain gauges, so that's the transducer electronic data sheet. So in here you can see it's called these things here, so that's CDAC, so that's compact data acquisition, which is that module thing down there, and then it tells you the port numbers, AI0, so that's those big Ethernet wires I plugged in, not the numbers that we were using the screwdriver for. So in this, again, that guide tells you how to set up all this, but you can set up your gauge resistance and all the electrical values that you require. Again, you just have to follow the guide. It tells you how to do the calculations and stuff in the guide.
Yeah, there's no load because just on one end, so all the load can escape. But when I'm clamping the other one, what you'll see is the load here will go a bit in compression. So it should. There we go. Because we grip, we do put some sample a bit in compression, right? So you always want to keep that because you always want your real load on the machine. So when there's nothing on. Okay?
Compression. So instead of zeroing that, you use the hand controller to move the crosshead up very slightly. That'll do for zero.
We did move the crosshead of 8 micrometers, and that's just enough to get back to the real loads. Right.
Straight.
Yes. DIC then the system here, right? Should we zero the strains, or that's fine?
No, because it's similar to the load cell like that. Is what I think actually happens with a sample that feeds form that much.
Okay.
That's a very small deformation, 150 microstrain, so 10,000 microstrain is 1%.
So that's fine. Alright, so these are actually, I think every time we just messed it up, it's the other way around.
It is unidirectional, so it'll be doing weird things from 45 for it.
No, but see, this should go here and this should go here, and I think we just, the 1 and the 3 is not, well, it's no big deal, that's for sure.
Yeah, you just swap around in your data.
Yeah.
You'll get all the columns, all this data.
The idea is not to have these, is to have the two lines sticking to one another, right? And this index here is deformation, it's microstrain.
I think that's meant to be actually percent. I don't know why it says index, but I thought I converted it from microstrain to percent for the graphs. You put it on micro strain, see what it does.
Gives you a lot of time. I'll put it back on per person, people or less on strain. Oopsie.
So there is definitely a chance that I've not set up the strain gauge properly in terms of the electronic values that you give it. So you give it calibration in terms of millivolts per volts that you for it. Get to that another time. But each strain gauge comes with specifications about it. So it's exact resistance and a gauge factor. I think what I might have done here is not use the correct gauge factor, which is why the strain is reading about twice what it should be.
And just strain
Because we're at 2.4% and we expect this to break at what, 1.8% or something? Is that right, Paul?
Should.
171.9.
So
Interesting.
I definitely need to look at the calibration for these gauges.
Yeah, look, because when I'm putting strain 3 and 4, which are, you know, strain 3 and 4, still they are not still sticking to one another. So somehow working hand in hand. So if you were to have to change a bunch of things, just take this route. You can change you can change everything there. Yes. What is it? That you can't is the input. So if you want to bring some hardware, well, yeah, you would have to go through this whole thing, right? It's just
So
it's yeah.
So this is diagnostic utility that tells you details about the machine and what's connected to it and calibrations and that sort of thing. So in here there's this thing called NI DAC, which lists all the available devices. So there's ones that are available that aren't linked to the machine and ones that are. So I've moved all the ones that are connected over to this side and then click on the modules and hopefully. So that brings up each port on that module. So there's 4 ports and you calibrate them with voltage ranges and what gauges you're trying, so it's like a half bridge it's called, and voltage excitations and that sort of thing. So it's all explained in here again. So this is a bit of a bible for setting up strain gauges on this machine. If any of you are actually planning to use strain gauges yourself reasonably soon, I'd recommend just coming and practicing for like several hours, setting up gauges and stuff. It's not something you should just jump into.